Hello. Yes, hello everyone. Welcome on YourPedia platform. I hope you all are fine. Please confirm my voice is clear, guys. Anyone, please confirm. You are getting voice. So, guys, in today's session, we are going to solve heat transfer problems, heat transfer questions for HPCL examination. So, different questions I picked from various topics like conduction, convection, radiation, heat exchanger. So, I came up with 50 important questions from this particular subject, guys. Heat transfer. I hope through these 50 questions you will be able to revise the entire subject. That is the only purpose, guys. The purpose of this class is to revise the entire important topics related to this particular subject. Okay, and I hope you will like this session because I picked a question in that manner. Some questions are very beautiful, different question. You are going to find out in this session. Okay, and some questions are direct also, because in HPCL they're not going to ask you very much depth question. Okay, direct question can also be there, but yes, some questions are unique in their own way. Okay, so let's start our today's session. I will try to complete this session in close to 18-19 minutes. So let's start. So I'm putting here question in front of you. It's my request to all of you guys, please participate. Okay, don't sit ideal, you need to answer. Okay, if you're getting answer, it's very fine, it's good. You can mention in the comment box, okay sir, I'm getting this answer. If you're not getting, then also you need to try. Okay, so don't listen only, observing. If you're only observing, that may help you, but it is good to observe, and at the same time it is good to practice. Okay, so practice with me so that you will be able to revise the entire subject. So let me put it here. The question number 1, guys, in front of you. So this is question number 1 in front of you, guys. What is the question? There is a cane. Okay, there is a cane. A cane is taken out from a refrigerator. Okay, at a temperature what? 0 degrees Celsius. The atmospheric temperature is 25 degrees Celsius. If T1 is the time taken to heat from 0 to 5 degrees Celsius, then T2 is the time taken from 10 to 15 degrees Celsius. Then what will be the relationship between T1 T2? What will be the relationship between T1 T2? Dhruva, for that you can talk with Gurvinder sir. There are so many videos, theory videos available on the YourPedia channel. Okay, panel. So you can have discussion with Gurvinder sir. He can guide you how, so that you will be able to watch those theory classes. Okay, so for that you can talk with our executive. So guys, whenever a Newtonian heating or cooling takes place, the rate of cooling or rate of heating decreases. In case of Newtonian heating or Newtonian cooling, the temperature decreases. So this is for what? This is for cooling. This is cooling curve. Okay, and this kind of curve you are going to get in heating. Heating में कुछ इस तरह का curve मिलता है. So this is the curve in case of what? Heating. Okay, so whether you are carrying out heating or cooling, the rate of cooling or heating, ये जो rate है आपका, what is rate? Rate means dt by dt, the rate of change of temperature with the time. This is known as rate of cooling. Okay, or rate of heating. So you can observe it here. So this is temperature versus time plot. Okay, temperature versus time plot. So whether you are carrying out cooling or you are carrying out heating, the rate of heating or rate of cooling always decreases with time. Okay, so when the can is at 0 degrees Celsius, you are bringing it to 5 degrees Celsius, the temperature difference is much higher, the heat transfer will be much faster, so the T1 time taken will be lesser. But again further, the temperature change from 10 to 15 will be much slower. Why? Because the rate of heat transfer will be lesser. Okay, so the rate of heating or rate of cooling decreases. That's why the T2 time will be more than T1. T2 क्या होगा बच्चों? More than T1. That's why the right answer is B, not C. Most of the student answered C. रोकी ने आंसर सी आंसर किया. रोकी ही बार बार आंसर कर रहा है. रोकी आपने 4-5 बार आंसर किया. Every time you answered wrong. So the right answer is B. T1 is less than T1. Okay, so this is a direct basic question. I hope this is clear. Let us move to this question. This is very different question, guys. जिसने ये सोल्व किया, it means your concept is good in this subject, heat transfer. Related to this transient heat conduction. So what is the question, guys? A body cools from temperature 3T to 2T. So this is the initial temperature. Let me tell you, okay, so that you will be able to apply the formula. So this is initial temperature, and this is what final temperature. So body cools from 3T to 2T in 10 minutes. When the room temperature is T, assuming that Newton's law of cooling is applicable, the temperature change of the body at the end of next 10 minutes. Next 10 minutes means from 2T to what will be the final temperature. यहाँ पे final temperature क्या होगा? Okay, in next 10 minutes, in initial 10 minutes, temperature changes from 3T to 2T. What will be the temperature change in next 10 minutes? Okay, so what will be the final temperature when the initial temperature is 2T, final temperature is T final? So he's asking you this T final after again 10 minutes. I hope this question is very much clear to all. So how to solve this question, guys? इस question को कैसे solve करोगे? How to solve this question? Very different question, guys. So how to solve this? You know, whenever we carry out Newtonian heating or cooling, we can use this formula. What is that? When lump analysis is applicable, you can write it here: Ti minus T infinity divided by T minus T infinity equal to e की power Ha by rho Vc into tau. Tau या T, you can write it here. Okay, this you can write it as some e की power, some constant, some lambda into T also, because H is a constant. For example, for a particular condition, H is not going to change. Area of the body is constant, density is constant, volume is constant, specific heat is constant. So all these things are constant. So Ti minus T infinity by T minus T infinity, that is equal to e की power lambda T, where lambda is a constant. So this you can put it here and you will get two equations. What are those two equations, guys? In first case, the initial temperature is 3T. The infinity means surrounding temperature is T. So 3T minus T divided by, what is T? T is the final temperature. So what is the final temperature in first case? The final temperature is 2T minus again T, that is equal to e की power lambda into time. How much is time, guys? How much is time? This is time, not, okay, this is time, small t only. So this is time. How much is time, guys, in first case? The time is 10 minutes only. Okay, 10 minutes. The time is 10 minutes. So I'm not converting here any units. Okay, so this is first equation. Similarly, second equation, how you will get, guys? For second case, what is the initial temperature? The initial temperature is 2T. The surrounding temperature remains T only. Okay, the final temperature we want to find out. Okay, and the surrounding temperature was T only. This is equal to what? Again e की power lambda into 10 minutes. Yes or no? Because we want to find out the final temperature after 10 minutes. Okay, so this is equation 1, this is equation 2. I hope this equation is very much clear. 3T minus T, 2T minus T equal to e की power lambda T. Lambda is constant, time is also constant, because in the same time duration we want to find out the final temperature. Okay, so if you will divide equation 1 by 2, अगर आप equation 1 को 2 से divide करोगे, so you can write this both are same. So 1 equal to what? 1 किसके equal आ जाएगा? From this minus this you will have 2T by T, 2T by T divided by what? T by T final minus T. Okay, so this is equal to what? This is equal to 1. ये किसके equal है? 1 के. Further solving this, you can write it here: 2T by T, that is equal to what? T by T final minus T. Yes or no, guys? So this equation you will get. This equation you will get. Okay, so if you will solve this, what you will get, guys? इसको solve करोगे तो क्या आ जाएगा? 2T final minus 2T, that is equal to what? T. Okay, and T final equal to 3T by 2. T final equal to what? 3T by 2, guys. So how many of you are getting this answer? Final temperature is 3 by 2T, means the B is the right answer, guys. Option B क्या हो जाएगा? Answer हो जाएगा. Okay, so question is very simple. We are using the basic formula only, e की power h a by rho vc, and you know this particular term is also known as what? Time constant. ये जो term है इसमें rho vc by ha, this is known as a time constant. बच्चों इसी को क्या बोलते हैं? Time constant. Okay, the time taken by the body or a thermocouple to decrease its the temperature difference to the 63% of the initial temperature difference, that is known as what? Time constant. So time constant क्या होता है? It is directly proportional to what? Density. More is the time constant, the body is going to take much time to decrease its temperature. So for a thermocouple we want a lesser time constant, and when you will have lesser time constant, when the convection heat transfer coefficient is higher, specific heat is lesser, density is lesser, volume is lesser, so he can ask you how you can decrease the time constant. Because if you want more sensitivity, you want a thermocouple which is very quick to read, okay, which is very fast in reading any particular temperature, so means you want a very less time constant. So time constant lesser means sensitivity is more. And how you can increase the sensitivity? How we can increase? By increasing the h value. Okay, चलिए. So I hope this question is very much clear. Option B is the right answer. कितने बच्चे इसको आंसर कर पाए? लेट मी चेक. बी बहुत कम काफी बच्चों ने आंसर किया. मोली, अंकित गुप्ता, सार्थक. बच्चों आपका आंसर बिल्कुल सही है. बी इज द राइट आंसर. चलिए लेट अस मूव टू नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 3. देखो क्वेश्चन नंबर 3 है आपके सामने. ए ब्लैक बॉडी radiates 20 watts at temperature 227 degrees Celsius. If the temperature of the black body is changed to 727 degrees Celsius, then the radiating power will be. कितना radiating power हो जाएगा बच्चों? बहुत सिंपल क्वेश्चन है. This is very simple direct question. You know guys, the hemispherical emissive power of a black body is directly proportional to fourth power of its absolute temperature. Yes or no? So if you want to write the ratio of EB1 to the EB2, this is nothing but what? T1 की power 4 to the T2 की power 4. So how much is T1? T1 is this 500 की power 4. T2 is what? Because you need to take the temperature in Kelvin, absolute temperature. How much is this guys? This is 1000 की power 4. Solving this, what you will get? You will get 1 by 2 की power 4. So this is nothing but 1 by 16. Okay. So hemispherical emissive power is going to increase by 16 times. If you are increasing the temperature from this to this, the hemispherical emissive power becomes 16 times. Okay. And if hemispherical emissive power is becoming 16 times, the area is same. Area आप क्या कर रहे हो? Same है. So the radiation heat transfer will increase by what? 16 times. So 20 into 16 कितना हो जाएगा? It will be 320 watt. Okay. So the radiation power will be what? 320 watts. Okay. Radiation power क्या होती है बच्चों? Heat transfer by radiation is nothing but the hemispherical emissive power into what? Area. So keeping the same area, the radiation emissive power will increase by what? 16 times it. It means 20 multiplied by 16, you will get 320 watts. Chaliye, let us move to next question guys. Question number 4. So the radiation emitted by a star A. So there are two bodies. There is a star A, okay, and there is sun. So the radiation emitted by star is 10,000 times that of the sun. Radiation emitted by star, radiation emitted by sun, this is what? 10,000 times. कितना है ये? 10,000 times. Okay. So if the surface area of the sun and star is this, दोनों का surface temperature दिया है, is asking you the ratio of the radii of the star and sun. What will be the ratio of the radii of the star and sun? Star and sun की radii का ratio क्या होगा? You know guys, this is nothing but what? इसको हमने क्या लिखा था? Area star का into what? Hemispherical emissive power of star, area of sun into hemispherical emissive power of sun. Both you can consider as a black body. The sun and star both you can consider as a black body. Okay. So actually, you know, these are like a spherical body. So area will be what? Area will be something like 4 pi r square. Suppose the projected area if you are taking, so it will be like what? Or the surface area if you are taking, so the surface area will be what? The surface area will be 4 pi r square. Surface area for a sphere. Okay. So this is actually a ratio. So 4 pi will be cancelled out. So you can write it as what? The radius of star ka square divided by radius of sun square into what? Hemispherical emissive power of star by sun. Okay. And this is equal to what guys? This is equal to the sigma. Sigma will be cancelled out. Temperature of sun ki power 4 means 2000 divided by 6000 ki power 4. Why guys? Because the star temperature is given to you this, and the sun temperature is given to you 6000 Kelvin. Okay, so you need to check it here. The temperature of the star is 2000 and the temperature of sun is 6000. So if you will take it here, solving this, you will get the ratio of the star radius, ratio of star square by ratio of radius of sun square, that is equal to what? 10,000 into. Solving this guys, what you will get? You will get 1 by 3 ki power 4, and 3 ki power 4 it will be what? 81. But 81 you need to multiply here. So this is this. Okay. So this is actually a square guys, but we don't want square. We want the ratio of the radius. So the ratio of the radius means radius of star divided by radius of sun. It is under root of this. इस पूरे का under root हो जाएगा. Yes or no? And what will be the under root of this guys? इसका under root क्या हो जाएगा? Under root will be 100 into 9. So it will be what? 900. Okay. So it will be 900 guys. So right answer क्या हो जाएगा बच्चों? The right answer will be C, 900 ratio 1. Okay. I hope this is clear to all guys. The answer for this question is C. How many answered this question? Ashutosh, Shivang, yes, Chanda. Very good, guys. C is the right answer for this question. तो आपको क्वेश्चन समझना है. It is very easy. चलिए, let us move to next question, guys. फिफ्थ क्वेश्चन पे मूव करते हैं. This is different, slightly different. Okay, so some questions are very much direct, also some are different. Okay, so don't feel ki yes sir, some are difficult question, but these are very direct. Okay, so please try this question. There is a sphere, and that sphere is kind of black body. एक sphere है, उस sphere को you can consider like a black body, and this sphere is at a temperature 600 Kelvin, is placed in an environment of 200 Kelvin. Its cooling rate is H. Cooling rate क्या है बच्चों? H. Considering only radiation. Considering only radiation, the cooling rate is H. If the temperature is reduced to 400 Kelvin, then the rate of cooling rate in the same environment will be. So initially, when the temperature is this, considering the radiation effect only, the rate of cooling is H. Now, if the temperature is decreased to 400 Kelvin, what will be the rate of cooling? Ankit, what do you want? Like the previous question? I'm not getting your point. Which you need? Like this is I need to repeat or what? This question. Okay, chaliye, I will wait for your reply. So in this question, guys, how to solve? Let me give you some hint, guys. You know, the heat transfer by radiation. Heat transfer by radiation. वो क्या होता है बच्चों? How much is the radiation heat transfer? This is emissivity sigma area into temperature of surface की power 4 minus temperature of surrounding की power 4. Yes or no? A kind of small body in a large enclosure. Yes or no? A small body in a large enclosure. So this will be what kind of radiation heat transfer? Q radiation, emissivity of the body, Stephen Boltzmann constant, area of the body, 600 की power 4 minus 200 की power 4. And this is equal to what, guys? This is equal to the mass Cp dt by dt. Whatever a body is radiating heat, the net radiation heat exchange from a body, that is equal to what? That is equal to the decrease in internal energy of the body. Yes or no? A body, if you are having a body, so how you can write the energy balance for that? Whatever is the Q lost from the body or net radiation heat exchange between the body and the atmosphere, that is equal to what? The decrease in internal energy of the body. And that decrease in internal energy, you can write it as mc dt by dt. Okay, so this dt by dt is nothing but what? इसी को क्या बोलते हैं? Rate of cooling या heating. Cooling rate. So this is cooling rate because we are considering a cooling case. So this is nothing but cooling rate. Okay. So now if you'll observe it here, these all things are constant. ये जितनी भी चीजें हैं सारी क्या है? Constant है बच्चों. This is also constant. So the rate of cooling dt by d this. Okay, let me use some another color, guys. मैं कुछ अलग screen choose करता हूँ. मैं ये वाला करता हूँ. Okay. Yes. Okay, so the rate of cooling dt by dt, can I write it here, is directly proportional to what? The temperature difference. The temperature difference, yes or no? This is equal to what? The temperature surface की power 4 minus T infinity की power 4. Yes or no? Because the emissivity is constant, sigma is constant, area is constant, mc, all are constant. Okay, so can I write it here? The rate of cooling in first case is H. Initially, the rate of cooling is H. Okay. Finally, the rate of cooling is X. We don't know what is that, but we are interested in finding out this. So this is rate of cooling in first case. This is rate of cooling in second case. So this is equal to what, guys? The initial case 600 की power 4 minus 200 की power 4 divided by the second case when the temperature is 400. So it is 400 की power 4 minus 200 की power 4. Are you getting, guys? Okay. So solving this, what you will get if you will take 200 की power 4 common. अगर आप इसको common ले लेते हैं, what you will get inside? You will get 3 की power 4 minus 1. Again, if you will take 200 की power 4 common, what you will get? You will get 2 की power 4 minus 1. Okay, so this will cancel out. And further solving, you will get this what, guys? You will get this 80, because 81 minus 1 you will get 80, and this will be what? 16 minus 1, this will be 15. Further solving, you will get what? 51136, and this will be 3. 16/3. Okay, so the final rate of cooling X, the final rate of cooling X will be what, guys? It will be 3/16H. Final rate of cooling क्या हो जाएगा बच्चों? It will be 3/16H. Okay, 3/16H. So the right answer will be what, guys? Option A is the right answer. Option A क्या हो जाएगा बच्चों? This is the right answer for this question. So how many obtained this answer? A. एक बच्चे ने आंसर किया है शायद. भूपिंदर B is not right. देखो कैसे, if you are getting 16/3 from, you need to apply some mind. What? How the rate of cooling can increase when the temperature is decreasing? Initially the temperature difference is 600 and the 200. The temperature is very higher. Now the temperature is lesser. So the rate of cooling is going to decrease or increase? That is definitely going to decrease. So how you can answer 16/3? Because if the answer is 16/3, the rate of cooling, it means it is increasing. The rate of cooling is more than H. That is not possible. Rate of cooling is going to decrease only. Okay. Obviously, it is not a case of convection. This is a case of radiation. So you need not to take here the temperature difference. आपको क्या लेना पड़ेगा? Power 4. Temperature of surface की power 4 minus temperature of surrounding की power 4. Okay, I hope this is clear. चलिए, let's move to the 6th question. So a black body, there is a black body at a temperature this. एक black body है इस particular temperature पे 5760. The energy radiation emitted by the body at wavelength 250 nanometer is U1. 250 nanometer पे the energy emitted is U1. At 500 nanometer, the energy emitted is U2. At 1000 nanometer, the energy emitted is U3. So Young's constant, Young's displacement law, lambda m, the product of the wavelength corresponding to maximum spectral emissive power and the absolute temperature of the body, that is equal to some constant. Okay, actually we write this constant as 2898 micrometer Kelvin, but यहाँ पे उसने कुछ approximate value दे दी है. How much is the value? He is giving you 288. Okay, 2880 micrometer Kelvin. Okay, so I'm not writing in nanometer, I'm writing in micrometer. So this value he has given you. The Young's constant is what? 288.10⁶ nanometer Kelvin. So this you can write it as like this. Okay, so he is giving you some approximate value, so that calculation will be easy. So he's asking you which of the following will be right. Guys, if you will plot here a graph between the spectral emissive power, EB lambda, what's his lambda plot at a particular temperature. At a particular temperature, if you will plot, according to Planck's law, we know the EB lambda is a function of what? Lambda and T. The spectral emissive power of a black body is a function of lambda, wavelength, and absolute temperature of the body. EB lambda is a function of lambda and T. That is Planck's law. And according to that law, we know initially when the wavelength is going to increase, the EB lambda is also going to increase. It becomes maximum, and then again it will start decreasing. Okay. And what is this, guys? This is the wavelength corresponding to maximum spectral emissive power. This is known as lambda m. So this particular lambda m, what is this lambda m? This is the wavelength corresponding to maximum spectral emissive power. Okay. So this entire plot we are having at this particular temperature, 5760 Kelvin. Okay. So from this, if I will ask you, can you find out this lambda m? क्या आप lambda m बता सकते हो? Yes, sir. We can find out. This is 2880 divided by what? Temperature. How much is the temperature? Temperature is this 5760. Okay. So solving this, what you will get? You will get 0.5 micrometer Kelvin. 0.5 micrometer Kelvin. Okay. Can I write it as 500 nanometer Kelvin? क्या मैं इसको 500 nanometer Kelvin लिख सकता हूं बच्चों? Yes. So this particular wavelength, okay, this particular wavelength is nothing but 500 nanometer Kelvin. Oh, sorry, 500 nanometer only, not nanometer Kelvin. So we are getting the wavelength only. So this is 500 nanometer. Okay. So this particular wavelength, the wavelength corresponding to maximum spectral emissive power is what? 500 nanometer. So obviously the energy also, what is Young's displacement law? A body at high temperature emits radiation of the shorter wavelength. Low temperature body emits radiation of higher wavelength, longer wavelength. Longer wavelength की radiations कौन सी body emit करती है? Low temperature body. High temperature body emits radiation of shorter wavelength. Okay, and most of the radiations emitted by the body will be in this range only, guys. Most of the radiations emitted will be in this range only. So that's why at a wavelength of 500 Newton meter, the energy emitted is U2. So easily you can answer U2 will be more than U1. Why? Because U1 are the energy emitted at a wavelength 250 nanometer. So 250 will be here somewhere, 250 nanometer. Okay, and at 1000 nanometer you will have here 1000 nanometer. So at 1000 nanometer the radiations emitted will be negligible, guys. At 1000 nanometer the radiation will be negligible. Most of the radiations emitted will be in this, at this particular wavelength only, 500 nanometer. That's why we can answer U2 is greater than U1. तो आंसर डी क्या हो जाएगा बच्चों? ऑप्शन डी इज द राइट आंसर. Fine. So only you need to check. First, you need to check what is the wavelength corresponding to maximum spectral emissive power. Accordingly, you will be easily able to find out. You know, the most of the radiations emitted by body in which particular range, the wavelength corresponding to the maximum spectral emissive power. Chaliye. Let us move to the question number 7. Question number 7. So this is comparatively easy, direct question, guys. I hope you all will be easily able to solve this. ये comparatively easy question है बच्चों, and I am expecting answer from all. Please try to answer this question. A black body has maximum wavelength. That wavelength maximum doesn't mean maximum wavelength. Maximum wavelength means the wavelength corresponding to the maximum spectral emissive power. So lambda m at this particular temperature, its corresponding wavelength at a temperature 3000 will be what? बहुत easy question है. You know, guys, lambda m1 into t1 that is equal to lambda m2 into t2 that is equal to lambda m3 into t3. That is a constant. ये क्या होता है? Constant होता है बच्चों हमेशा. This is constant. This is nothing but Wing's displacement law. The product of wavelength corresponding to the maximum spectral emissive power and the absolute temperature, that is a constant. और वो constant कितना होता है? That constant is how much? That constant is 2898 micrometer Kelvin. Okay, so only you need to compare what the, in first case the wavelength, first this is the wavelength, the temperature is 2000. In second case the wavelength we want to find out, ये wavelength हम निकालना चाह रहे हैं, and the temperature is what? 3000. Okay, so from this lambda m2 will be what, guys? It will be 2 by 3 lambda m. Very easy, very simple question. Okay, तो क्या हो जाएगा बच्चों? lambda m2 means in second case the lambda m2 will be what? 2 by 3 of the lambda m, means option B is the right answer, guys. Option B क्या हो जाएगा बच्चों? This is the answer for this question. चलिए, let us move to next question. Question number 8. Question number 8. The thermal conductivity of non-metallic amorphous solid. Non-metallic amorphous solid like glass. Okay. Non-metallic amorphous solid with decrease in temperature. टेम्परेचर के डिक्रीज करने से, टेम्परेचर को डिक्रीज करोगे तो क्या होगा बच्चों? The lattice vibration, in case of solid we are having what? Solids में how conduction takes place? In solids conduction takes place by lattice vibration of the molecule and free electron transfer. But in amorphous solid there is no free electron transfer. Okay, so the heat transfer will be there by lattice vibration. But at low temperature the lattice vibration will be less. Lattice vibration भी क्या होगा बच्चों? That will also be less. ये भी क्या होगा? Less होगा. Low temperature पे less होगा, high temperature पे high होगा. So when you are decreasing the temperature of a non-metallic amorphous solid, the conductivity is also going to what? Decrease. Conductivity क्या कर जाएगी बच्चों? आपका decrease कर जाएगी. So non-metallic amorphous solid like glass, they are having high conductivity at high temperature, low conductivity at what? Low temperature. तो डिक्रीज इन टेम्परेचर के साथ कंडक्टिविटी क्या करेगी? डिक्रीज करेगी. तो ऑप्शन बी क्या हो जाएगा? दिस इज द राइट आंसर. ओके, ऑप्शन बी इज द राइट आंसर. चलिए, लेट अस मूव टू नेक्स्ट क्वेश्चन. क्वेश्चन नंबर 9. क्वेश्चन नंबर 9 गाइस इन फ्रंट ऑफ यू. द इंसुलेटिंग एबिलिटी. थोड़ा पढ़ के आंसर करना बच्चों. Don't be in hurry. You need to read the entire question and then only you need to answer. The insulating ability. He is asking you the insulating ability of an insulator with the presence of moisture. With moisture के presence की वजह से, with the presence of moisture, the insulating ability of a material insulator is going to increase, decrease, remain unaffected, may increase, decrease depending on the temperature and thickness of the insulation, or none of these. What you will answer, guys? What you will answer for this question? Please read the entire question and then only answer. The insulating ability of an insulator. Guys, you know, moisture content जब बढ़ता है, अगर moisture बढ़ता है तो क्या होता है बच्चों? Moisture content अगर बढ़ता है तो conductivity क्या करती है? बढ़ेगी. Okay, suppose you are having a kind of material, dry hai to conductivity will be less. If it is wet, moisture, that material gained some moisture from the atmosphere, so the conductivity will be higher. So moisture की वजह से conductivity बढ़ता है. So due to the moisture content, conductivity is going to increase. So if conductivity is increasing, the insulating ability is going to decrease. What you need to understand, he is not asking about conductivity, he is asking about the insulating ability. So insulating ability is going to decrease. ओके, कंडक्टिविटी बढ़ जाएगा तो इंसुलेटिंग एबिलिटी डिक्रीज कर जाएगा बच्चों. व्हाई? Because what is the insulator? Insulator is a material which is having very low thermal conductivity. What do you want from a insulator? We want so that thermal conductivity will be less. If less is the thermal conductivity, less will be the heat transfer. Yes or no? Because conductivity is nothing but the ability of a material to conduct heat. Okay, so if the conductivity is increasing due to the presence of the moisture content, the insulating ability is going to decrease. I hope this is clear. So the right answer is not increase, the decrease is the right answer, guys. Fine. So that's why I mentioned 2-3 times. I mentioned please read the entire question, then only try to answer. Decrease answer हो जाएगा बच्चों, because he is not asking you about conductivity, he is asking you about the insulating ability. So you can write it here. The insulating ability is इनवर्सली प्रोपोर्शनल टू के. जितना के ज्यादा होगा इंसुलेटिंग एबिलिटी कम होगी बच्चों. चलिए नेक्स्ट क्वेश्चन इन फ्रंट ऑफ यू. कोर्क इज ए गुड इंसुलेटर. कोर्क क्या एक अच्छा इंसुलेटर है. व्हाई कोर्क इज ए गुड इंसुलेटर गाइस? बिकॉज देयर इज नो फ्री इलेक्ट्रॉन प्रेजेंट, ये भी सही है. इट इज हैविंग लो एटम कोलाइडिंग एफिशिएंसी, ये भी बिल्कुल सही है. इट इज हैविंग लो डेंसिटी, कोर्क का डेंसिटी बहुत कम होता है. यस. इट इज हैविंग पोरस बॉडी, बिल्कुल एयर ट्रैप कर देता है, पोरस बॉडी होती है. सो दिस इज आल्सो राइट. सो ऑल ऑफ द अबव इज द राइट आंसर फॉर दिस कोर्क. Cork is a very good insulator, guys. We use many applications are there for cork. So all of the above is the right answer for this question. चलिए नेक्स्ट क्वेश्चन मूव करते हैं. क्वेश्चन नंबर 11. Okay. So this is next question, guys, in front of you. चलिए. So according to Kirchhoff's law, what is Kirchhoff's law? A body is in thermal equilibrium. The emissivity is equal to what? Absorptivity. Absorptivity equal to emissivity. This is Kirchhoff's law of thermal radiation. A good absorber is also a good emitter. Okay. When the body is in thermal equilibrium. So here he is asking you, according to Kirchhoff's law, the ratio of emissive power means EB to the absorptivity. E by alpha, थोड़ा सा कंफ्यूज करके पूछ रहा है आपसे. The ratio of E by alpha is equal to what? किसके इक्वल होगा? The ratio of E by alpha is equal to what? Okay, you know alpha is equal to emissivity. So this is nothing but E by emissivity, not EB. This is not EB, this is E. Okay, this is E. Okay, so E by alpha or nothing but what? E by emissivity. ये क्या होता है? This is nothing but what? EB. Why? Because the E by EB, the ratio of hemispherical emissive power of a body to the hemispherical emissive power of a black body, the ratio of emissive power of a body, any general body, to the hemispherical emissive power of a black body, that is known as what? Emissivity. So emissivity gives us some kind of reference related to the emissive power of a body in comparison to the black body. Okay, so this ratio emissive power to the absorptivity is nothing but what? The hemispherical emissive power of a black body. तो option D क्या हो जाएगा बच्चों? is the right answer. Okay, option D is the right answer. Fine. चलिए, let us move to next question. Question number 12. Depending on the radiating properties, black body क्या होता है बच्चों? What is a black body? Let me write it here quickly. You can also answer. Black body. Black body क्या होता है बच्चों? Black body is a very good absorber, जिसके लिए absorptivity is 1, reflectivity 0, transmissivity 0. What is a white body? Sir, white body is a ideal reflector. White body क्या होता है? Sir, white body is a ideal reflector. Means for a white body, the reflectivity equal to 1, absorptivity equal to 0, transmissivity equal to 0. What is a opaque body? Opaque body क्या होता है? Opaque body. For a opaque body, the transmissivity is 0. It means the sum of absorptivity plus reflectivity equal to 1. Okay, so black body, white body, opaque body, transparent body. For an ideal transparent body, the transmissivity will be equal to 1. Okay, here he is asking you about the black body. So for a black body, the absorptivity equal to 1. So option A itself is the right answer, guys. Option A क्या हो जाएगा? This is the right answer. Fine. चलिए, let us move to next question. Question number 13. Question number 13. This question you need to answer. You know, guys, the heat transfer equation, this particular equation is known as what? You know, in heat transfer, we are having conduction heat transfer equation del 2T by del X square plus del 2T by del Y square plus del 2T by del Z square. This is three-dimensional heat conduction equation, generalized heat conduction equation in Cartesian coordinate. Okay. Okay. So this particular equation, guys, I hope you all remember this particular equation. Okay, so this is generalized heat conduction equation in Cartesian coordinates we are having, guys. Okay, now in this equation, guys, in this equation, if you are having this 0 and this 0, agar ye bhi 0 hai, means no heat generation and steady state. Agar steady state bhi hai, if you are having steady state, okay, and no heat generation, steady state as well as no heat generation, no heat generation, तो equation कौन सा बन जाएगा? The equation becomes Laplace equation, del 2t equal to 0. Okay, so this particular equation is known as what? Laplace equation. इस इक्वेशन को हम क्या बोलते हैं बच्चों? Laplace equation. So the right answer for this question will be what? Option A. Option A क्या हो जाएगा? This is the right answer, guys. Okay, can you tell me what is this equation? इस equation को क्या बोलते हैं? Del 2t plus q dot by k equal to 0, this particular equation, and del 2t equal to 1 by alpha del t by del t. Can you tell me this name of second equation and third equation? This particular equation is known as Laplace. Fine. What is the name of this equation? इस equation को क्या बोलते हैं बच्चों? What is the name of equation 2 and 3? Please answer. Yes. Equation 2 and equation 3, guys. Del 2t plus q dot g by k equal to 0, and the bottom one del 2t equal to 1 by alpha del t by del t. Fine, guys. Please try to answer. Okay. Any responses? Poisson's ratio. Very good, guys. The upper one is known as what? Poisson's equation. This is the Poisson's equation. And the lower one, this particular equation is known as Fourier equation. So this is Fourier's equation. This is generalized conduction equation, guys. This particular equation, this is generalized conduction equation, three-dimensional generalized heat conduction equation with heat generation and unsteady steady dono case. Okay. So if no heat generation, steady state, you will have Laplace equation. If there is only steady state but heat generation is there, then you will have the Poisson's equation. And if there is unsteady state but no heat generation, you will have Fourier's equation. Okay. Chaliye. So for this question, the answer is option A. Let us move to next question, question number 14. Figure show, there is no figure given, guys, so I am drawing here. मैं आपको draw कर रहा हूँ. You need to answer. ये बहुत important question बन जाता है. आपको answer करना है. So I am giving you different curves. मैं आपको अलग-अलग curve दे रहा हूँ. So something like this. I am giving you different curves. Okay. So I am giving you different curves, guys. These are the different curves given. So suppose the lowermost curve is A, this is B, this is C, and the upper one is D. Okay. Obviously, this is the high temperature, guys. Here the temperature is, this is hot temperature body, this is T1, this is T2, okay, and T1 is greater than T2, something like this. Means the heat transfer is taking place in this direction. Heat transfer is taking place in this direction. Q conduction. Now, can you tell me this A belongs to what kind of body, what kind of material? B curves belong to what kind of material? C belongs to what kind of material? And D belongs to what kind of material? First, answer this question. Okay, in this question, he is asking you, in this given figure, the variation of temperature across the thickness is given. The variation of temperature across the thickness is given. As you can check it here. for with the different thermal conductivity. Obviously these are the different thermal conductivity, you need to answer. So the curve belongs to D. The D curve D will be applicable to a material having thermal conductivity. What kind of thermal conductivity? Which is increasing with increasing temperature, decreasing with increasing temperature, the conductivity is very large, is constant at all temperature, none of the above. What you will answer guys? D curve D belongs to what? ये जो D curve है, this uppermost curve, this D belongs to what kind of material guys? D किसके लिए belong करता है? Increases, decreases, the conductivity is very large, is constant at all temperature, none of the above. क्या आंसर करोगे आप? What do you answer guys? Guys, D belongs to, you know, when the conductivity is very high, conductivity जब बहुत high होता है तो क्या होता है? The temperature gradient is very less, you know. So if a material is having very high conductivity, the temperature gradient dt by dx will be very, very less. More is the conductivity, less is the temperature gradient. So you can check it here. This is almost like a straight line. Means that whatever temperature you are having here, the same is penetrated to this particular surface. So the temperature penetration is much faster. Means the conductivity is very high. So this D curve belongs to a material which is having very, very high thermal conductivity. So C answer हो जाएगा बच्चों. D is for a material having very, very high conductivity. A किसके लिए बच्चों? कर्व A के लिए क्या है? A के लिए कंडक्टिविटी क्या कर रहा है? K इक्वल टू K नॉट इंटू 1 माइनस अल्फा T, जिसका कंडक्टिविटी इज डिक्रीजिंग विद द इंक्रीज इन टेम्परेचर. So for curve A, you can check it here. As the temperature is decreasing, the temperature gradient is increasing. So temperature gradient is increasing means temperature gradient यहाँ पे क्या है? बहुत ज्यादा है. यहाँ पे temperature gradient क्या है? कम है. Means at high temperature the conductivity is lesser. At low temperature the conductivity is more. So if conductivity is lesser at high temperature, it means with the increasing temperature conductivity is decreasing. So curve A किसके लिए होगा? This is for what? This is for known metals. This is for known metals. Okay. कर्व C किसके लिए हो जाएगा बच्चों? कर्व C will be for what? Conductivity is increasing with the temperature 1 plus alpha T. Okay, conductivity is increasing with the temperature guys. Let me write it here again. So curve C is for what? Okay, नहीं decrease करेगा ना. This is decreasing guys, so this is not for known metals, this is for metals. Because metals के लिए conductivity क्या करता है? Decrease करता है. With the increasing temperature, conductivity of metal decreases, whereas known metals का तो बढ़ता है बच्चों. So this is for metals. This curve A is for metals. Curve C is for known metals guys. Known metals का conductivity क्या करता है? बढ़ता है. So for metals, temperature increases, conductivity decreases. For known metals, temperature increases, conductivity also increases guys. I hope this is clear. So curve A belongs to these kind of materials जिनका conductivity बढ़ रहा है मतलब metal. Curve C belongs to known metals जिनका conductivity बढ़ेगा with the increasing temperature. You can check it here. At high temperature, the temperature gradient is very less. At low temperature, the temperature gradient is more. Means at low temperature, conductivity is less. At high temperature, conductivity is more. Means conductivity is increasing with the increasing temperature. So if conductivity is increasing with the increasing temperature, means you are having a known metal. Metals ka conductivity decreases. Why? Because with the increase in temperature, lattice vibration increases, but increased lattice vibration restrict the movement or penetration of the free electron. So due to reduction in the free electron transfer, the conductivity of metals decreases with the increase in temperature. Whereas non-metals, the heat transfer is majorly due to the lattice vibration only. Non-metals, there is no free electron. That's why conductivity increases with the increase in temperature. Fine, चलिए क्वेश्चन नंबर 15 क्वेश्चन में मूव करते हैं, थोड़ा जल्दी करते हैं इसको, चलिए सो दैट क्विकली वी विल बी एबल टू सोल्व. थोड़ा सा स्पीड बढ़ाते हैं बच्चों अभी. चलिए सो नेक्स्ट क्वेश्चन नंबर 15. 40% of the radiation energy emitted on the surface, radiation energy on the surface of a body is reflected back. Means reflectivity कितना है बच्चों? 40% you are reflecting means reflectivity is 0.4. Transmissivity is this. Transmissivity कितना है? 0.515. So for any surface, you know, the sum of absorptivity, reflectivity plus transmissivity equal to 1 means absorptivity equal to 1 minus 0.4 minus 0.15. So this is equal to what guys? 0.45. So if body is having absorptivity 0.5 means it will have emissivity also 0.5, because according to Kirchhoff's law, a good absorber is also a good emitter. Okay. So alpha is equal to 0.45. So emissivity is also 0.45. Option A क्या हो जाएगा बच्चों? This is the right answer. Fine. चलिए, let us move to question number 16. What is a gray body? Please read the question, try to answer. A gray body is one whose emissivity. ग्रे बॉडी क्या होता है बच्चों? जिसके लिए emissivity, the spectral emissivity is equal to emissivity, and that is a constant. So emissivity is not a function of lambda and t. So for a gray body, the hemispherical emissivity, the emissivity is not changing with lambda and t. But what is this emissivity? Spectral emissivity is nothing but the ratio of the spectral emissive power of a non-black body to the spectral emissive power of a black body. This is known as spectral emissivity. So if this spectral emissivity is equal to emissivity, this is for a what kind of surface? A gray surface. So a gray surface is a surface for which the spectral emissivity is independent of the wavelength and temperature. So the right answer for this question is what? Does not vary with the temperature and wavelength. Option D क्या हो जाएगा बच्चों? This is the right answer. Varies with temperature, varies with wavelength, varies with both? No. D is the right answer, guys. Fine. चलिए. Let us move to next question. Question number 17. Question number 17. Please answer. So there is a long semicircular duct. ये duct है बच्चों. This is a duct, something like this. अगर आपको duct बनाना है, so you can draw a duct like this. ये duct कुछ ऐसा है बच्चों. Duct कुछ ऐसा है. This is not a surface. This is a duct. अगर अंदर का भी बनाना चाहो तो you can draw. So this will be something like this. Something like this. Okay. So this is a duct. This is a duct, something like this. So there is a long circular duct shown in figure. This upper surface is A2. Upper surface क्या है? A2 है. और जो bottom वाला surface है, this is A1. He is asking you what F22. आपसे F22 पूछ रहा है बच्चों. He is asking you F22. Very simple question, guys. You know, according to the reciprocity theorem, for the shape factor, we know F11A1, this is equal to F12A2. Yes or no? So F11 is a flat surface. Obviously, this duct, the ground is like a flat surface. Okay. So F11 is equal to what? 1. F11 कितना है? 1 है. This is self-shape factor of 1. 1 is a flat surface and that is equal to 1. So from this we will get F12 equal to A1 by A2. Yes or no, guys? So F12 equal to, oh sorry, not F11. Yes, इसको मैं लिखता हूँ F12. हाँ, चलो मैं इसको यहाँ ऐसा नहीं लिखता. So मैं थोड़ा सा इसमें गलत लिख दिया. Let me again write this equation, guys. So this is F12A1. This is F12A1. For flat surface, the self-shape factor is 0. Okay, F11 तो 0 जगह मैंने लिख दिया F11. So this is not F11, this is F12. Okay, for a flat surface, the self-shape factor is 0. Why? Because the radiations emitted by a flat surface are not going to reach to the same surface. So F12 will be 1. Okay, F11 will be 0. So this is F12A1 equal to F21A2, something like this. Okay, so this is a flat surface. So for a flat surface, this is equal to 1. So you will have F21 equal to what? A1 by A2. Fine. So now what is A1, guys? A1 कितना है? A1 can I write it as the L into D, where L is the length of the duct. L is the length of the duct and D is the diameter. Yes or no? So this is L and this diameter is what? D. ये कितना है? D. So this is L into D. What is the area of this? इसका area कितना हो जाएगा? It will be pi D by 2. Because the perimeter of the entire circle is pi d, so the perimeter of half circle, semicircle will be pi d by 2. So perimeter into length. Okay. Solving this, what you will get, guys? LD will be cancelled out. You will have what? 2 by pi. 2 by pi. So this is F12, but we don't want F12. We want F22. You know, guys, there is a summation rule also. F21 plus F22. This is equal to 1. So solving this, you will get F22 equal to 1 minus F21. This is equal to 1 minus 2 by pi. Okay, 1 minus 2 by pi. Okay, तो इसको आंसर करो because we want F22. अपने को क्या चाहिए बच्चों? We want F22. So what answer you are getting, guys, through this? इसको सोल्व करके क्या आंसर आ रहा है? So pi is nothing but 3.14. So 3.14 minus 2 divided by 3.14. So this is 1.14 divided by 3.14. देखो ये रेशो कितना आ रहा है? 1.14 divided by 3.14. तो ये तो नहीं आ सकता कभी भी. 50% भी नहीं है, you can check it here, this is much lesser than 50%, ये इसके 50% से कम है, this is also not right. 50% नहीं हो सकता तो 70% भी नहीं हो सकता, you can check, this will come out right answer, you can check it here, this ratio you can check. This 1.14 is much lesser than the 50%. इसका 50% कितना होगा? It will be what? 1.57. 1.57 will be the 50% of this. So ये तीन आंसर तो आप वैसे ही रिमूव कर सकते हो. 0.36 will be the right answer. ऑप्शन डी क्या हो जाएगा बच्चों? This is the right answer for this. Fine. चलिए. Let us move to question number 18. A temperature distribution in a stainless steel fin, thermal conductivity 0.17 watt per centimeter degree Celsius, of constant cross-sectional area 2 centimeter square, length 1 centimeter, is exposed to ambient temperature of this, is given by this particular equation. Okay, so T minus T infinity is equal to 3x square minus 5x plus. What is asking you? Is asking you Q convection from the fin. कितना फिन से कन्वेक्शन हो रहा है गाइस? क्यू कन्वेक्शन इज नथिंग बट क्यू कंडक्शन. जितना कंडक्शन टिप पे हो रहा है, whatever heat, no tip, root, whatever conduction is taking place at the root of the fin, so whatever heat is entering into the fin by conduction, that is equal to q convection from the fin, and that q conduction is nothing but minus ka dt by dx at x equal to 0. So we are interested in finding out the Q conduction because fin के अंदर देखो, अगर जो fin है आपका, fin के अंदर root पे heat कैसे enter करता है बच्चों? At root heat enters by what? Conduction. Root पे heat कैसे enter करता है? Conduction से, Q conduction. So from the surface, in surface the conduction also takes place, and at the same time convection will also takes place. So whatever is the heat convection from the tip, that is equal to Q conduction at the root. Okay, at root Q conduction is minus K dt by dx at x equal to 0. So solving this, you will get dt by dx at x equal to 0. So this will come out what? इसको देखो 6x minus 5. So this will come out minus 5. ये कितना आ जाएगा बच्चों? minus 5. Okay, so in this equation you can check the temperature is given in degree Celsius, that x is given in centimeter. So you don't need to convert any unit. आपको कोई unit conversion नहीं करना है बच्चों, because all things are given in centimeter only. So conductivity is also given in watt per centimeter. So keep in this the same unit 0.17. Area is given you 2 centimeter. Keep it 2 centimeter only. This is also in what? Kelvin means Celsius, because temperature difference will be same whether you are having in Kelvin or degree Celsius. So Kelvin or degree Celsius per centimeter. Okay, so this is the temperature gradient. So this is what? This is also in watt per meter, centimeter. This is per centimeter, this is centimeter square. So unit will be automatically balanced. Okay, so minus 5. Solving this, what you will get guys? You will get 1.7 watt. इसको solve करोगे तो क्या आ जाएगा बच्चों? 1.7 watt. Option C क्या हो जाएगा? This is the right answer. Okay, so how many got answer C? Shubhajit, there is अभी तक तो कोई ऐसा information नहीं है. Till now there is no such information related to the exam on 7th August. अभी 7 अगस्त को कैसे हो जाएगा बच्चों? 7 अगस्त the exam is not possible. Okay, चलिए, let us move to the next question guys. Question number 19. So there are two lists given. This is list 1, this is list 2. He is asking you to match list 1 with the list 2. Match list 1 with the list 2. So in list 1 you are having time constant, you are having Biot number, you are having critical thickness, you are having Nusselt number. Time constant क्या होता है बच्चों? Time constant del T star is nothing but what? Rho V C by HA. So you can check it here. Time constant is matching with what? 4. Okay, critical thickness क्या होता है बच्चों? Critical thickness of insulation for a wire is nothing but K by H, where K is the conductivity of the wire, H is the convection heat transfer coefficient. Biot number is the internal conduction resistance to the external convection resistance. So it is HD by K, where K is the conductivity of solid. So B is matching with what? 3. And Nusselt number is also HD by K, but the K is the conductivity of fluid. That's why this is matching with this. तो A B C को अगर मैं मैच करूं, A B C D, तो क्या मैचिंग हो जाएगी बच्चों? A मैच कर गया था 4 के साथ, B is matching with 3, C is matching with 2 and D is matching with 1. So 4 3 2 1 क्या हो जाएगा? हमारा आंसर हो जाएगा 4 3 2 1 मींस ऑप्शन ए ही आंसर हो जाएगा हमारा. ठीक है, ऑप्शन ए क्या हो जाएगा बच्चों? दिस इज द राइट आंसर. आई होप यू नो द डिफरेंस बिटवीन द नसेल्ट नंबर एंड बायट नंबर बच्चों. बायट और नसेल्ट नंबर बोथ आर वेरी इंपॉर्टेंट. बायट नंबर वी यूज इन द ट्रांजिएंट हीट कंडक्शन. बायट नंबर लेस देन 0.1 तो क्या होता है हमारा? तो क्या होता है हमारा? लंप्ड एनालिसिस क्या होती है हमारी? एप्लीकेबल होती है. और बायट नंबर क्या होता है? इंटरनल कंडक्शन रेजिस्टेंस टू द एक्सटर्नल कन्वेक्शन रेजिस्टेंस. सो इट इज नथिंग बट hd by k, where k is the conductivity of solid, whereas Nusselt number is a ratio of q convection to the q conduction. So in Nusselt number you are having hd by k, where k is the conductivity of fluid. चलिए, let us move to next question, question number 20. Please read this and try to answer. In a current carrying conductor, if the radius of conductor is less than the critical radius, radius is less than critical radius, you know guys. So if you will take it here, the q, and here if you will draw r, you will have some plot like this. आपके पास कुछ ऐसा plot होता है बच्चों. Initially with the increase in the radius, the heat transfer increases, it becomes maximum, and then it will start decreasing. So the heat transfer is maximum at what? At some critical radius. Heat transfer आपका maximum कहाँ पे होता है? At critical radius. So if radius is lesser than this, you are in this zone 1, radius is lesser than critical radius, so increasing the thickness of insulation is going to increase the heat loss. If you are in zone 2, then increasing the thickness of insulation is going to decrease the heat transfer. So you are in this range guys. R radius, R in this zone, R is less than RC. So if R is less than RC means increasing the radius of insulation, the heat transfer is going to increase. Heat transfer क्या करेगा बच्चों? Increase करेगा. So what is asking you? In a current carrying conductor, if the radius of conductor is less than the critical radius, the addition of electrical insulation is desirable. Why it is desirable guys? To reduce the heat loss? Reduce the heat loss? No, we don't want to reduce the heat loss. We want to increase the heat loss from the conductor, therefore enables the conductor to carry a higher current. Yes, you know guys, Q lost is equal to I square RT. So if the heat lost from the material is sufficient, so its current carrying capacity is going to increase. If heat lost is less, means there is some kind of accumulation of heat is taking place, then the wire is going to melt. So to keep the wire safe, you need to supply the less current. Okay, so if you increase the current carrying capacity of a wire, then heat loss is required to be higher, so that there must be less accumulation of heat. Okay, so we want a more heat transfer, so that its current carrying capacity will increase. Option B क्या हो जाएगा is the right answer. चलिए, let us move to next question, question number 21. Consider the following statement pertaining to heat transfer from the fin. Okay, fin से क्या क्या चीजें ठीक है? Fins are equally effective irrespective of whether they are on the hot side or cold side. No, this is not right, guys. You know, effectiveness of fin is nothing but Q with the fin to the Q without fin. Q without fin. Okay, Q with fin is nothing but what? Under root HPKA, considering the fin is of infinite length. Okay, and without fin it will be what? Under root H, no, not H, this is HA theta naught. Solving this, you will get effectiveness of fin is equal to what? क्या जाएगा? Under root KP by HA. So effectiveness of fin is equal to this, considering the infinitely long fin. You know guys, fins are more effective if the convection heat transfer coefficient is lesser. Generally we introduce fin in a particular location, at a particular location where the convection heat transfer is lesser. Okay, so it depends on that, not on the hot and cold side. So this is not right. Temperature along the fin is variable, and hence the rate of heat transfer varies along the elements of the fin. This is also right. Obviously, along the length of the fin, the heat temperature varies, and temperature varies, due to that heat transfer also varies. Fin may be made up of material having the higher thermal conductivity than the base material. This half line is fine guys. We want fin material of what? Higher thermal conductivity, so that more and more will be the heat transfer, more will be the effectiveness also, because effectiveness is directly proportional to conductivity. But it is not like that you can attach a fin of some higher conductivity than the base material. It is not like that. Why? Because fins are like the projections on a base material. So fins are the integral part. Okay, these are casted actually like the projections from the base material. So fins are not having the different material from your base material. They are having the same material. So this is also not right, guys. ये सही नहीं है. We want conductivity higher, but it doesn't mean कि surface का base material will have another conductivity and you are going to weld the fin. It's not like that. You are not going to weld the material, or you are not going to screw or any other kind of joining process you are going to use. It is not like that. You are going to extrude the base material. Okay, so some kind of projections you are going to have. Voice is not coming. Okay. How many students are not getting voice, guys? Please confirm. So Ravi is saying voice is not coming. Anyone also please confirm, guys. Only Ravi is not getting voice, or all students are not getting voice, guys? aa raha hai Ravi, I think there is some problem at your end. Ankit is getting voice, and if Ankit is getting voice, I think there is some at your end. Okay, Piyush, thank you. Ankit, chaliye, thank you, Piyush. So this is also wrong. Fins must be arranged at right angle to the direction of flow. This is also right. So 2 and 4 are right. We can go with what, guys? Option B क्या हो जाएगा is the right answer. चलिए, let us move to next question. Question number 22. The heat is flowing through two cylindrical rods of same material. The diameter of the rods are in the ratio of this. The length ratios are in this range, in this ratio. The temperature difference between their ends is same. The ratio of the heat flows through them. So there are two rods. कुछ ऐसा roads है बच्चों. So these are the two rods. Diameter कुछ ऐसा है, तो इसको मैं थोड़ा पतला दिखा देता हूँ, इसको थोड़ा मोटा दिखा देता हूँ. So this is road 1 and this is road 2. Both are having same temperature difference. तो यहाँ पे temperature T1 है, यहाँ पे temperature क्या है, T2 है. Okay. But what is the difference? The heat flowing through them of the same material. So this is also having conductivity K, this is also having conductivity K, because both are made up of the same material. Diameter are in this ratio, means for this the diameter D1 to the D2. D1 to D2 is what? 1:2. Okay. Their length ratio, अच्छा, length is not same, guys. Length same नहीं है. So let me take another case. Length is not same. Length is in the ratio of 2:1. तो इसको मैं थोड़ा छोटा दिखा देता हूँ. Something like this. Okay. So the length is not same. So this is having length what? This is having length L1, this is having length L2, and L1 by L2 is what? 2:1. Both are having different length. Okay, but temperature difference is same. Here the temperature is T1, here the temperature is T2, here the temperature is T1, here also the temperature is T2. The temperature difference is same. Now what is asking you? The ratio of the heat flow. इसमें और इसमें heat flow का ratio क्या होगा? You know, guys, Q1 by Q2 is nothing but delta T by इसका length means L1 by K1A divided by delta T. This is for 1. This is delta T2 divided by L2 by K2A. Okay, so solving this, what you will get, guys? Delta T same. In this case delta T, in this case delta T same. Okay, their conductivity is also same. Why? Because both are made up of the same material. Both are made up of same material, so their conductivity is also same. दोनों का conductivity क्या है बच्चों? This is also same. Solving this, what you will get? You will get a ratio. आपके पास क्या ratio आ जाएगा? इसको solve करोगे, you will get A1 by L1 equal to what? इसको solve करोगे तो आ जाएगा L2 by A2. A1 by L1 into L2 by A2. Okay, so if you'll put it here, A1 by A2. What is A1 by A2, guys? A1 by A2 का ratio क्या हो जाएगा? A1 by A2. A1 will be what? Pi D square, and D1 square. This is pi D2 square. So it is nothing but what? 1 by D1 by D2 square. So D1 by D2 square is nothing but 1 by 4, and this is not L1 by L2. This is L2 by L1. So L1 by L2 is this. So L2 by L1 will be what? It will be 1 by 2. Okay, reverse हो जाएगा. So this. So you will get what, guys? You will get answer 1:8. Answer क्या आ जाएगा आपका? 1:8. Option D. थोड़ा सा भी अगर आपने mistake की, you will get the wrong answer, guys. You need to take the diameter square. Okay, diameter square, guys. Is it clear, guys? So you can write Q1 by Q2. ऐसा भी आप लिख सकते हो अगर आप लिखना चाहो. So delta T1 by K1 into not K1, L by K1. So L1 by K1. और इसमें मैं उल्टा कर देता हूं तो क्या आ जाएगा आपका? This is L1 by K1A into what? Delta T2. So from this also you can check. यहां से भी आप चेक कर सकते हो बच्चों. So this is L2. This is what? L2. Fine. So ऐसा लिखो, जैसे मर्जी लिखो आप. This will cancel out. Conductivity will also cancel out. You will get what, guys? You will get L2 by L1 into what? A1 by A2. So this will come out A1 by A2 into L2 by L1. So you will get the answer, guys, 1 by 8, not 1 by 4. 1 by 8 is the right answer, guys. Mari Muthu, please check. 1 by 8 is the right answer for this question. Okay. So this is question number 22. And for this question 22, 1 by 8 is the right answer, guys. D is the right answer, not 1 by 4. Please check. So I think you are making some kind of calculation mistake. That's why you are getting 1:4. Fine. Let us move to next question, question number 23. For cooking the food, which of the following type of utensil is most suitable? कुकिंग फूड के लिए किस तरह के यूटेंसिल्स, किस तरह के बर्तन हम प्रेफर करते हैं बच्चों? व्हाट काइंड ऑफ यूटेंसिल्स वी प्रेफर फॉर कुकिंग फूड? हाई स्पेसिफिक हीट, लो कंडक्टिविटी, नो. हाई स्पेसिफिक हीट, हाई कंडक्टिविटी, नो. लो स्पेसिफिक हीट, लो कंडक्टिविटी, नो. We want specific heat lesser and conductivity higher. What do we want, guys? We want heat storage lesser. We want a utensil which is going to store less heat, which is going to transfer more heat. So we want a conductivity higher and the specific heat lesser. What is specific heat? Amount of heat required to raise the temperature of a unit mass of a substance by unit degree Celsius. So we want specific heat lesser so that heat storage will be less, transfer will be more. So D is the right answer, guys. Low specific heat, high thermal conductivity. Can you solve this question, guys? This is very beautiful question actually. बहुत अच्छा क्वेश्चन है, छोटा पैकेट है ये, बिल्कुल अच्छा क्वेश्चन है. 6 identical metallic rods. So these are 6 identical metallic rods. जितनी भी ये rods आपको दिख रही हैं, these all are identical, guys. ये सारी की सारी rods क्या हैं? Identical हैं. Okay. They are joined as shown in the pattern, shown in the figure. Part A and D are maintained at this temperature. तो यहाँ पे टेम्परेचर कितना है? 60 डिग्री सेल्सियस. And here the temperature is 240 degrees Celsius. The temperature at the junction B. He is asking you the temperature at junction B. आपसे junction B पे temperature पूछ रहा है बच्चों. What is the temperature at junction B? Can you find out temperature at junction B, guys? Guys, what will be the heat transfer? All rods are of same kind. Means how much is the resistance of AB? Let me write it here. This is having resistance R. This is also having resistance R. This is also having resistance R. All are identical, guys. What he mentioned, 6 rods are identical. They are identical in all sense. Means length, their area, their conductivity, all are identical. So they all are having same resistance. So what will be the total resistance, guys? Summation of total resistance क्या बता सकते हो मेरे को? What will be the summation of total resistance? Can you tell me, guys? Yes. In this case, sir, here the network will be something like this. Okay, ऐसे कुछ network बनेगा. Okay, so this is resistance R, this is R, this is R, this is also R. तो इन दोनों का इक्विवेलेंट क्या हो जाएगा? What will be the not two? There are no two resistance. ये दो हैं बच्चों. तो मैं जल्दी जल्दी बना देता हूँ, यहीं पे दिखा देता हूँ बच्चों. So this is first resistance, something like this, and this is second one. This is another one. Here also you will have, this is first, this is another one, and you will have this. Okay, so this is R, this is R, this is R, this is R, and this is also R, this is also R. Okay, I'm just explaining you, that's why I'm taking much time, otherwise this is very direct question. So what will be the equivalent resistance of this? इसका equivalent क्या हो जाएगा बच्चों? R equivalent. इसका equivalent क्या हो जाएगा? That easily you can find out. 1 by R equivalent is equal to 1 by 2R plus 1 by 2R. So it will be what, guys? 2R you can take LCM, so it will be 1 plus 1, so it will be 2, so it will be 1 by R. It means the equivalent of these resistance, guys, the equivalent of these resistance will be what? R only. The equivalent of these resistance is what? R. So you can reduce this entire network like this: one resistance, second resistance, third resistance. So now this is R, this is R, this is also R. So the equivalent of this, guys, the equivalent of this we have obtained. इसका हमने इक्विवेलेंट निकाल लिया R. So total resistance कितनी हो जाएगी नेटवर्क में? How much is the total resistance in the network? The total resistance is 3R. Okay. Now what is heat transfer, guys? Sir, the heat transfer is nothing but the temperature difference by the summation of total resistance. Sir, the temperature difference is 240 minus 60 means 180 divided by 3R. This is the total heat transfer. Okay. This is the total heat transfer. Fine. Sir, the same heat transfer, because when the members are in series, whatever heat transfer is taking place through them, the same is the heat transfer taking place through this A and B. Yes or no? So I can equate this This I can equate with what, guys? TB minus 60 divided by R. What is the temperature here? Here the temperature is TB because heat transfer is taking place in this direction, because this is the higher temperature, this is the lower temperature. So heat transfer is taking place in this direction, and in steady state, the same heat transfer is going to take place. Whatever heat is entering, the same is conducting and same is going out. So this is the heat transfer, guys, 180 by 3R. This is equal to TB minus TA, and TA is equal to 60 divided by R. Solving this, what you will get, guys? You will get this will cancel out, and this will be 60. So TB will come out 120, guys. बहुत अच्छा क्वेश्चन है. TB will come out 120 degrees Celsius. So answer क्या हो जाएगा for this question? The answer will be option A. Option A, 120 degrees Celsius. Very good. Piyush Moli, very good. A is the right answer for this question. चलिए, let us move to next question, question number 25. The ratio of thermal conductivity of two rods of different material. दो rods का conductivity इस ratio में है. The rods are of same area, same thermal resistance, will have same length. What will be the length ratio? दोनों का length ratio पूछ रहा है. Okay, so very simple question, guys. What is he mentioned here? The rods of same area and same thermal resistance, guys. दोनों का resistance क्या है? Same है. So if the resistance of one equal to resistance of two, what it means? It means L1 by K1 A1, that is equal to L2 by K2 A2. Yes or no? So he is talking about axial heat conduction only, not radial heat conduction. Axial heat conduction. So L1 by K1 A1, this is equal to L2 by K2 A2. So both material are of different material in this conductivity ratio 5:4. Same area, दोनों को area क्या है? Same है. So A1 will be cancel out. So he is asking you what length ratio. So L1 by L2 is nothing but K1 by K2. So conductivity ratio is given to you 5/4. So the same will be the ratio of what? Length. So whatever conductivity ratio you are having, the same will be the length ratio. So option D क्या हो जाएगा बच्चों? Right answer हो जाएगा. Option D 5:4 is the right answer. Okay, 5:4. चलिए नेक्स्ट क्वेश्चन मूव करते हैं. क्वेश्चन नंबर 26. Consider the composite slab consisting of two different materials having equal thickness. एक स्लैब है जिसमें दो मटेरियल्स लगे हैं बच्चों, दोनों का थिकनेस क्या है? सेम है. Okay, so this is material 1, this is material 2, something like this. Both are having same thickness. दोनों का thickness क्या है? सेम है. So this is also L, this is also L. Both are having same thickness. And thermal conductivities are K and 2K. दोनों का कंडक्टिविटी कितना है? K and 2K respectively. The equivalent thermal conductivity. आपसे इसका equivalent conductivity पूछ रहा है बच्चों. He's not asking you the resistance, total resistance. He's asking you equivalent conductivity. Guys, this entire composite slab you can replace by a simple slab of the length 2L. आप इस composite slab को replace कर सकते हो with a slab of length 2L and with a conductivity K equivalent. So when you will say this is the equivalent of this, when you will say when both are having same resistance, जब इसका resistance और इसका resistance same होगा, then only you will say कि this is the equivalent of this. What is the resistance of this, guys? इसका resistance क्या है? So 1 by R equivalent, because they are in series, इसका equivalent क्या हो जाएगा? 1 by R1. R1 क्या है बच्चों? L1 by K1A, या L by K लिख देता हूं मैं. So this is what, because length is same, so L by Ka, so Ka it will go like this, plus what is this resistance of this? So it will be 1 by R2. So R2 will be what, guys? L by again Ka, so K 2K into A. Solving this, what you will get, guys? You will get the LCM 1 by R equivalent equal to 3Ka by L. Yes or no? So R equivalent will be L by 3Ka. So this is R equivalent here. What is R equivalent here, guys? यहाँ पे R equivalent क्या है? यहाँ पे R equivalent, resistance equivalent is nothing but 2L by K equivalent into A. Comparing this, can you tell me what will be the K equivalent? K equivalent कितना हो जाएगा? So if you will compare this and this, what you will get? L by 3Ka equal to 2L by K equivalent into A. So if you will compare this will cancel out. This will cancel out. We will get K equivalent equal to, देखो कुछ गड़बड़ तो नहीं हुआ? Let me check it here. So this is 1 by R1 equal to what? 1 by R1, R equivalent equal, अच्छा, they are in series, guys. They are in series. ये series में है. They are in series. So we need to directly add these. अपने को इनको directly add करना पड़ेगा. So they are in series. ओके, दे आर नॉट इन पैरेलल, सो आर इक्वलेंट यहां पे क्या हो जाएगा हमारा L by KA plus L by 2K A. Area is same. So solving this, what you will get? LCM 2KA. So this will be 2L plus L. So it will be 3L by 2KA. So this is R equivalent in first case. Okay, this is R equivalent in first case. So you can equate this with what? 2L by K equivalent into A. Okay, so now comparing this, we will get some answer. This will cancel out, area, LL will be also cancel out. What you will get? You will get K equivalent equal to 4K by 3. K equivalent equal to 4K by 3 guys. So what is the right answer guys? 4K by 3. Option C क्या हो जाएगा is the right answer. This is the equivalent conductivity. So earlier I have taken a kind of parallel case which is wrong. So these resistance are in series. So this will be the right answer guys. I hope this is now clear. You need to directly add. These are not in parallel, they are in series. So R equivalent will be R1 plus R2. So R1 is L by KA. This is L by 2KA. So this is the equivalent resistance of this network, this particular system, and for this you will get this. Comparing this, you will get R K equivalent. Fine. Chaliye. Let us move to next question 27. So this is 27th question guys in front of you. The coefficient of thermal conductivity of copper is 9 times than that of the steel. Conductivity जो copper का है, copper conductivity is 9 times the conductivity of brass. Okay, brass से जो conductivity है copper का, this is 9 times more. What will be the temperature at the junction? यहाँ पे junction temperature पूछ रहा है आपसे. Is asking you the junction temperature TJ. The length is given, this length is given, that here the temperature is given, here the temperature is given. Is asking you the junction temperature. Very simple. You can write Q because whatever Q is conducting from the copper, that the same Q is conducting from the steel because they are in series. So in series, the Q is same like the current. When resistance are in series, the same current flows through them. Similarly, when the members are in series, the same heat flows through them. So what is Q through copper rod? Q through copper rod is nothing but delta T means 100 minus Tj divided by iska length means 18. Keep it in centimeter only. L by Ka means conductivity of copper. Conductivity of copper is 9 times the conductivity of brass into area. This is equal to Tj minus here the temperature is 0 divided by this length is 6 divided by conductivity of brass into A. Only you need to compare this. आपको इसको compare करना है बच्चों. So comparing this will cancel out. This will cancel out. इसको यहाँ करोगे तो क्या आ जाएगा? It will be 3. इसको करोगे तो this will be 3. This will go up. So it will be 300 minus 3 Tj equal to Tj. So 4 Tj, junction temperature is 300. Solving this, you will get junction temperature 75 degrees Celsius. जंक्शन टेम्परेचर कितना आ जाएगा बच्चों आपका 75 डिग्री सेल्सियस. मतलब ऑप्शन ए क्या हो जाएगा इज द राइट आंसर. फाइन, ऑप्शन ए इज द राइट आंसर. वेरी गुड मोली. ऑप्शन ए हो जाएगा बच्चों राइट आंसर 75 डिग्री सेल्सियस. नेक्स्ट मूव करते हैं क्वेश्चन नंबर 28 पे. टू रोड्स ए एंड बी ऑफ इक्वल लेंथ. देखो ये अच्छी प्रैक्टिस है, आपको प्रैक्टिस करना है इन क्वेश्चंस का. देयर आर टू रोड्स ए एंड बी ऑफ इक्वल लेंथ. तो यहाँ पे कोई दो रोड हैं. ये एक रोड ए है, ओके, ये रोड बी है. बोथ आर ऑफ द इक्वल लेंथ, दोनों का लेंथ सेम है. सो दिस इज रोड ए, दिस इज रोड बी, बोथ आर ऑफ इक्वल लेंथ. दिस इज हैविंग एरिया A1, दिस इज हैविंग एरिया A2. ओके, दिस इज हैविंग कंडक्टिविटी K1, दिस इज हैविंग कंडक्टिविटी K2. फाइन. Same temperature difference. So here temperature is T1, here temperature is T2. So temperature difference is also same across them. Okay, now what is saying? The rate of heat transfer in the transmission in the two road will be same. The rate of heat transfer in the two road will be equal. कब equal होगा? When will the rate of heat transfer will be same, guys? In which case the heat transfer will be same? When K1A2 equal to K2A1, K1A1 equal to K2A2, K1 equal to K2, K1A1 square equal to K2A2 square. Guys, he is saying whatever is the heat transfer through this Q1, the same heat transfer is taking place through this, means Q1 equal to Q2, Q1 equal to Q2. So Q1, Q2 is nothing but what? Temperature drop across this. Temperature drop is same, divided by length is also same, conductivity is different, area is different. This is also in temperature difference same, length same, conductivity is different, area is different. Solving this, what you will get, guys? This will cancel out, this will cancel out. It means you will have same heat transfer only if the product of conductivity and area is same. Means K1 A1 equal to K2 A2. Option B is the right answer. Fine. चलिए, let us move to next question 29. जल्दी से सोल्व करते हैं बच्चों इसको. A slab consists of two parallel layers of copper and brass of the same thickness having same thermal conductivity in this ratio. Okay, two parallel layers of copper and brass. अभी दो parallel layer है बच्चों, दो parallel layer है आपके पास, एक copper का एक brass का. These are the two parallel layers. Slab consists of two parallel layers of copper and brass. चलो ऊपर कॉपर को रखते हैं बिकॉज पहले कॉपर बोल रहे हैं तो ऊपर कॉपर रख लेते हैं. दिस इज कॉपर, दिस इज ब्रास. हालांकि उससे कोई फर्क नहीं पड़ेगा. ओके, you can keep it brass upper above also, there is no such issue. Conductivity in this ratio means conductivity of copper is equal to 4 times of conductivity of brass. Now he is giving this particular ratio, so you need to take this only. If the face of brass is at 100 degrees Celsius and the copper is at 0 degrees Celsius, a slab consists of two parallel layers of copper, but now he is saying they are having different temperature, means you need to tilt it like that. तो ये पैरेलल नहीं है बच्चों, ये ऐसा अरेंजमेंट नहीं है. द अरेंजमेंट इज नॉट लाइक दिस, द अरेंजमेंट इज लाइक दिस. सो फर्स्ट यू नीड टू टेक द कॉपर एंड देन यू कैन टेक ब्रास और समथिंग लाइक दिस. सो दिस इज कॉपर, दिस इज ब्रास. दे आर नॉट पैरेलल. यहाँ पे पैरेलल नहीं होना चाहिए, यहाँ पे सीरीज होना चाहिए बच्चों. पैरेलल गलत हो जाएगा. देयर विल बी सीरीज. Their conductivity, so this conductivity of copper equal to 4 times of conductivity of brass. Fine. Their conductivity ratio is given. Now what is given you? The temperature at the brass face. Here the temperature is 100 degrees Celsius. Here the temperature is 0 degrees Celsius. Means heat is going to conduct in this direction. Heat is direction में conduct होगी बच्चों. Fine. The temperature at the interface. Similar kind of question guys. बड़ा ही similar kind of question है. आपसे यहाँ पे पूछ रहा है temperature at the junction. What is the temperature at the interface? Okay. Temperature at the interface. So the temperature at the interface will be 100 minus temperature at the interface Tj divided by two layers of copper and brass of same thickness. Same thickness means guys इन दोनों का जो thickness है, the length, that is same. So the L by conductivity of brass into area, this is equal to Tj minus 0 divided by same thickness L, conductivity of copper, and conductivity of copper is nothing but 4 times of the conductivity of brass. So you can write it here, 4 times of conductivity of brass into area. Solving this will be cancelled out, this will be cancelled out. You will have what guys? 100 minus Tj equal to 4 Tj. So 5 Tj equal to 100. So the junction temperature is 20 degrees Celsius. Junction temperature कितना आ जाएगा बच्चों? It will be 20 degrees Celsius. Option B क्या हो जाएगा? Is the right answer. Okay. Option B 20 degrees Celsius is the right answer. Let us move to next question. 30 question guys. Please try to answer this question. बहुत अच्छा क्वेश्चन है ये. आप इसमें मिस्टेक पक्का कर सकते हो. There are chances to make a kind of mistake in this question. एक slab consists of two parallel layers. एक slab है, ये दो parallel layer है बच्चों. These are the two parallel layer of two different materials of same thickness. इनका thickness same है. Okay, means this particular thickness is same. Having the conductivities K1 and K2. Conductivity कितना है? K1 and K2. He is asking you the equivalent conductivity. इस slab का equivalent conductivity. Guys, before this we have solved a case of finding out the equivalent conductivity when the members are in series. Now here the members are in parallel and he is asking you the equivalent conductivity. So how you can make a kind of equal system? इसका equivalent क्या होगा बच्चों? आप mistake क्या करोगे? इसका equivalent system जो लोगे आप, for that the area will be what guys? 2a. Area will be what guys? 2a. Okay, this is having area a, this is having area a. So the equivalent system will have area 2a. The length will be same, L only. Length will be same, L. Yeah, L या D लिख लो. So this will be D, this is also D. Now the conductivity is what? K equivalent. Okay, this is only you need to keep in mind. So इसका equivalent क्या होगा? Equivalent will be, you will have a slab of area 2a, conductivity K equivalent, length D. Now what is the resistance of this? इसका resistance क्या है? Resistance R equivalent here is nothing but what? इसका resistance क्या हो जाएगा? D by K equivalent into A? Yes or no? So this is the equivalent, resistance equivalent to A, not A. This is D divided by K equivalent into 2A. Okay. Now, how much is the equivalent resistance of this? इसका equivalent resistance क्या हो जाएगा? So 1 by R equivalent equal to 1 by R1. So 1 by R1 will be what, guys? This is K1A divided by D plus K2A divided by D. Yes or no? So solving this, what you will get? D will be the LCM. You will have K1A plus K2A. So this will be what? A by D into K1 plus K2. So this is 1 by R equivalent. Solving this, the R equivalent will be what? R equivalent will be D by A into K1 plus K2. D by A K1 plus K2. Now, can you equate this and this? This is equation 1, suppose this is equation 2. So if you'll compare this and this, D by A into K1 plus K2. What you will get, guys? Comparing this, you will get what? You will get K equivalent equal to, देखो D will cancel out, DA will cancel out. Okay, so K equivalent will be what? It will be K1 plus K2 divided by 2. So this only you need to keep in mind. If you are having resistance in parallel, okay, if you are having resistance in parallel, this is how to find out the equivalent resistance. Earlier we have solved a case when you are having resistance in what? Members in series. Fine. Okay, Ashish, thank you. Thank you very much. Chaliye, let us move to next question, question number 31. The two identical bodies, there are two identical bodies are made up of material for which the heat capacity, बहुत अच्छा क्वेश्चन है बच्चों, this is very very good question. देखो ये बहुत simple question है, but I can challenge here. 18 students are watching this. I can challenge only 4 or 5 will be able to answer this question. आपको सोचना है. Please guys, it's my request to all of you. Please try to answer this question. बहुत अच्छा question है. Two identical bodies are made up of material for which the heat capacity increases with temperature. Heat capacity temperature के साथ बढ़ जाता है. So one of these is at a temperature 100 degrees Celsius, while the other one is at a temperature 0 degrees Celsius. If two bodies are brought in contact, assuming no heat loss, मतलब outside कोई heat loss नहीं हो रहा है. So this is body 1, this is body 1, okay, and this is body 2. They are only exchanging heat. Okay, they are only exchanging heat. There is no heat loss outside. इससे अलग heat loss बाहर क्या हो रहा है? Zero. You know, in most of the thermodynamics problem we assume like that. So these are the only two bodies exchanging heat. There is no heat loss to the outside. Okay, but what is the difference? Body 1 का जो specific heat है, for these bodies, they are of the made up of a material for which the capacity increases with the increasing temperature. So one body is at a temperature 100 degrees Celsius, another one is at a temperature 0 degrees Celsius. So if the two bodies are brought in contact, assuming no heat loss, what will be the final temperature? Final temperature क्या होगा बच्चों? Can you answer this question, guys? Let me again read. Okay, let me again read it for you guys. Two identical bodies. So these two bodies are same. Identical means they are having same mass. Iska mass is same. Both are having same mass. They are identical in all manners. But the one is at 100, another one is at 0 degrees Celsius, and their capacity increases with temperature. What is capacity? Capacity means the product of MC या C बोल सकते हैं, because mass is same, because both are identical. So specific heat increases with increase in temperature. Temperature बढ़ता है तो specific heat बढ़ जाती है. टेम्परेचर बढ़ता है तो स्पेसिफिक हीट क्या हो जाती है बच्चों? बढ़ जाती है. ओके, व्हाट इज सेइंग? हीट कैपेसिटी इंक्रीजेस विद इंक्रीजिंग टेम्परेचर. So one of these is at a temperature 100, another one is at temperature 0 degrees Celsius. So if both the bodies are brought in contact, then what will be the final temperature? Final temperature will be 50, 0, more than 50, less than 50. What will you answer, guys? What will you answer for this question? Guys, 50 will be the final temperature. What do you need to think in this case? You know, they are only exchanging heat. So whatever heat lost by this is equal to heat gained by this. So mc dt of the one, that is equal to mc dt of 2. Yes or no? Or it is better to write it like this, because dt for this will be negative and dt for this will be positive. तो आप ऐसा लिख सकते हो mc dt1 that plus mc dt2 that is equal to what? Specific heat दोनों का different होगा. Why? Because they are at different temperature. They are identical, but they are having different specific heats. Why? Because they are at different temperature. So this is 0. Okay. Or what you can say? We can write it here. MC1 means T1 minus T final. That is equal to MC C2 T final minus T2. Okay. और T1 कितना है बच्चों? T1 is 100. T2 is what? T2 is 0. Okay. This is 0. This is 100. This is 0. Now they are identical. Their masses are same. Masses तो क्या है? Same है. So product of what? C1 into 100 minus TF equal to C2 into TF minus 0. This product is same, guys. इसका और इसका product क्या है? Same है. Now can you tell me which one is more? C1 is more or C2 is more, guys? Which one is more? C1 is more or C2 is more? Can you tell me, guys? C1 is more or C2 is more? This is the body at low temperature, C2. The body 2 is at low temperature. This body is at high temperature. It means C1 is more. Yes or no? C1 क्या है बच्चों? ज़्यादा है. C1 is more than C2. And if C1 is more than C2, from that you can conclude 100 minus TF is less than TF. Yes or no? 100 minus TF is less than TF. Are you getting this, guys? This you need to conclude from this. 100 minus TF is less than TF. Why? Because you are having the product of two quantities is equal. Means C1 into this is equal to C2 into this. But C1 is higher. Why C1 is higher? Because the body is at high temperature 100. This body is at low temperature. As he clearly mentioned, the heat capacity increases with the temperature. Okay, means C1 is more. And if C1 is more, so this quantity will be lesser than this. So now if you'll put it here 50-50. So here what you will have 50. 50 is less than 50. That is not right. 50 temperature you will get if their specific heat is not changing with temperature. Then equal final temperature will be 50 only if the specific heat is not changing. But here he has mentioned the specific heat is changing. That's why if you will put it here 45, अगर आप 45 put करते हो, what you will have? 100 minus 45. 55 is less than 45. Is it right? 55 is less than 45. No. So what will be TF, guys? TF will be more than 50. You can check it here. If you'll put it here 52 or 55. So suppose final temperature is 55. What you will get difference? Difference is 45. And yes, 45 is less than 55. So are you getting, guys? So final temperature will be what? It will be more than 50. So answer क्या हो जाएगा? Answer will be option C. I hope this is clear to all, guys. Option C क्या हो जाएगा is the right answer. Fine. Not B. B भी गलत है, 50 भी गलत है. Option C is the right answer. Fine, guys. Why actually I'm answering C? Is it right? समझ में आ रहा है? This product is same. This is more. That's why this will be less. And if this is less than this, T final will be more than 50. Yes. C is not constant. You cannot take C constant because clearly he has mentioned C is changing, guys. C, heat capacity. Heat capacity means the product of mass into specific heat. Mass you can take some common, means specific heat C is increasing. Okay, so the specific heat capacity multiplied by temperature difference. So specific heat is increasing. Okay, fine. Chaliye, let us move to next question 32. In heat transfer, which method is based on gravitational effect? कौन सा मेथड है जो ग्रेविटेशनल इफेक्ट पे बेस्ड करता है? ऑब्वियसली नेचुरल कन्वेक्शन. नेचुरल कन्वेक्शन क्या होता है बच्चों? नेचुरल और फ्री कन्वेक्शन इज takes place. This convection takes place by what? The buoyancy effect. Okay, due to the density difference. Okay, so the right answer for this question is what? The free or natural convection, because natural convection takes place by the gravitational effect. Okay, चलिए नेक्स्ट क्वेश्चन मूव करते हैं. क्वेश्चन नंबर 33 जल्दी से करते हैं. 33. The wavelength of maximum intensity of radiation emitted by sun is this and moon is this. sun का wavelength इतना बता रहा है, moon का इतना बता रहा है. ratio of their temperature. Very simple question, guys. You know the product of lambda into t equal to constant. So what is the wavelength of sun? sun का wavelength कितना है? 0.5 into 10 की power minus 6. Keep it same unit only. This is equal to temperature of sun. This is equal to wavelength of moon 10 की power minus 4 into temperature of moon. Solving this, what is asking me? That ratio of their temperature means temperature of sun to the temperature of moon. It will be what, guys? It will be 10 की power minus 4 divided by 0.5 into 10 की power minus 6. Solving this, you will have what? 10 की power 2 divided by 0.5, so it will be what guys, 100, 1000 divided by what, 5. ठीक है, ठीक लिखा है हमने, यस यस. तो इसको सोल्व करोगे, इट विल बी व्हाट गाइस, 200, it will be 200. Okay, it will be 200 guys, please check, because solving this will be cancelled out. You will have 10 की power minus 2, so this 10 की power minus 2 will go up, 10 की power 2, 10 की power 2 means 100. 100 को आप क्या लिख सकते हो, further you can multiply by 10, so you will have what, 1000 divided by 5, 200. So the ratio of their temperature will be what, 200:1. So option D क्या हो जाएगा बच्चों, is the right answer. Option D is the right answer. Very good, Molly. Molly is very quickly answering all the questions. Very good. Fine. Let us move to next question. Question number 34. Thermal conductivity of air with rise in temperature. Guys, conductivity of air is due to what? Molecular collision. And as the temperature of air increases, molecular collision increases, kinetic energy increases. More is the kinetic energy, more will be the number of collision, and more will be the conductivity. So temperature increases for air, its conductivity also increases. Guys, gases का जो conductivity है, gases का conductivity क्या करता है, बढ़ता है बच्चों. With the increase in temperature, conductivity क्या करता है, बढ़ता है. Conductivity increases with the increase in temperature. For what? Air, gases. Okay, चलिए तो आंसर क्या हो जाएगा for this question? The right answer is what? Increases. Option A is the right answer. Which of the following is the correct sequence? Which of the following is the correct sequence for alpha? Alpha का correct sequence पूछ रहा है बच्चों आपसे. What is alpha? Alpha is the thermal diffusivity. Alpha is known as thermal diffusivity. What is thermal diffusivity? It is the ratio of the conductivity to the heat capacity rate, K by rho Cp. It is the ability of a material to gain the solid surface hot bath temperature. So alpha is more for what? Alpha is more for gases. Alpha gases का क्या होता है बच्चों? लिक्विड से ज्यादा होता है. Although the conductivity of gases is much lesser than conductivity of liquid, but their heat capacity is also less. This is also less for gases. That's why alpha of gases is more than alpha of liquids. Okay, conductivity is less, but alpha is more. You know guys, if you are passing air over any kind of hot surface, अगर एयर को किसी hot surface के ऊपर पास कर रहे हो, so air is very quickly going to gain that temperature as compared to water. Obviously, the heat transfer will be more for water. Water is having more heat capacity. So if you are passing water over any surface, the heat transfer will be more in case of water. But I'm not asking you about the heat transfer. I'm telling you about what? I'm telling you about the temperature, ability of a body to gain the hot surface temperature when that fluid or body is introduced to that. So gases occupy the surface temperature very quickly. The penetration of temperature will be much faster in gases as compared to the penetration of temperature in liquids. Why? Because gases are having more thermal diffusivity. More is the thermal diffusivity, more is the Fourier number, more is the temperature penetration. That's why gases are very quickly they heated up, okay, when they passed over any kind of hot surface. So alpha is more for gases. Let us move to next question guys, 36. As the thickness of insulation around a heated cable gradually increases from zero, thickness आप zero से बढ़ा रहे हो तो क्या होगा बच्चों? Gradually you are increasing the thickness, so first the heat transfer is going to increase and then it will decrease. You know, all know very well, if you are increasing the radius of insulation, if you are increasing the thickness, means you are increasing the radius of insulation. So first, as you are increasing the radius, first Q is going to increase, it is going to become maximum, and this maximum heat transfer we will have corresponding to a radius known as critical radius. And after further increasing the radius more than the critical radius, the Q will start decreasing. So first it is going to increase, then decrease. C is the right answer. 37. A steel plate of thermal conductivity 50 watt per meter Kelvin, thickness 10 centimeter, passes a heat flux of this. If the temperature of the hot surface is this, what is the temperature of the cooler side? बहुत आसान क्वेश्चन है बच्चों. What is asking you here? The temperature of the hot side is 100. Is asking you the temperature on the cooler side. यहाँ पे temperature पूछ रहा है आपसे. Heat flux कितना दिया है? Heat flux is 25 kilowatt per meter square. So heat flux is also given to you. Heat flux is rate of heat transfer per unit area. Conductivity is also given to you. You know, guys, heat flux is nothing but the temperature difference 100 minus T2 divided by the resistance. And what is resistance? Resistance is B by Ka. So what is B? B is 10 centimeters. So 10 into 10 to the power minus 2. This is B. The thickness of this is B. Okay, 10 centimeter by K. How much is a K? K is 50. How much is the area? Area is 1. Why? Because we are having the heat flux. We are having the heat flux, guys. Okay, so solving this, what you will get? This will be what, guys? इसको solve करोगे तो क्या आ जाएगा? 5 आ जाएगा. So 5 you can write it here, and this you can write it here. So you will have what? You will have 25 into 10 की power minus 2 equal to क्या आ जाएगा? Yes, let me check it here. Yes, everything is fine. 10 centimeters, so 10 into 10 की power minus 3 divided by 50. Okay, what you need to check, guys? This is 25 kilowatt. Very small. 25 kilowatt per meter square. So this will be 25 into 10 की power 3. So this further you need to multiply by 10 की power 3. So this is equal to 5 into 100 minus T2. Okay. So solving this, what you will get, guys? This will cancel out. You will have 250 equal to 500 minus 5T2, or 5T2 equal to 250. So T2 equal to what? 50 degrees Celsius. T2 कितना आ जाएगा बच्चों? It will be 50 degrees Celsius. Fine. So how many of you are getting 50? Guys, 50C is the right answer for this question. चलिए check करना आप इसको. 50 is the right answer. Fine. So this is 25 kilowatt. So you need to take it 25 kilowatt, guys. These all things we are taking in SI units. So this also you need to convert. Fine. चलिए. So there is a composite wall of 3 layers. 3 layers का एक composite wall है, something like this. एक 3 layers का क्या है? Composite wall है, something like this. So this is having the length, thickness 0.3 meter. इसका 0.3 meter है. This is 0.2 meter, and this is suppose 0.1 meter. दिखने में बड़ा दिख रहा है, but forget about that. Okay. And thermal conductivities are in this. These are the thermal conductivities. इसका conductivity K1, K2, K3 all are given. So this is K1, this is K2, this is K3. Surface area सबका कितना है बच्चों? Area is 1 meter square. Area कितना है आपका? 1 meter square. Now what is asking you? The inner temperature, outer temperature difference is also given you. Heat transfer. He's asking you the heat transfer, guys. So heat transfer is nothing but the temperature difference. The temperature difference 1840 minus 340 divided by the resistance. These all are in series, guys. थोड़ा सा lengthy question बन सकता है, but it is very easy. These all are in series. So what is the resistance of this? The resistance of this is 0.3 divided by Ka, and how much is K? K is 0.6. तो solve करोगे तो it will come out 1 by 2. इसको solve करोगे, this will also come out what? 1 by 2. इसकी resistance भी 1 by 2 मतलब 0.5 आ जाएगी. So the resistance of 1, पहले का resistance कितना है? 0.5. Second का resistance will also come out what? 0.5. For second the resistance will come out to 1. So if you calculate the total resistance here, अगर आप total resistance निकालते हैं R total, so R total will be 0.5 plus 0.5 plus 1, so it will be 2. So 2. So this will be 1500 divided by 2, so it will be what? 750 watt per meter square. Why? Because we are taking area 1, so it will be 750 watt per meter square. Or if you are taking area 1 only, so you can write it as 750 watt also. So answer क्या हो जाएगा बच्चों? Option D is the right answer. Okay, option D is the answer for this question. Fine. Let us move to next question 39 जल्दी से. बच्चों आज 39 पे एंड 40 पे एंड कर देते हैं बच्चों. Let us end this session at 40 questions. 10 questions I will share in the common group. You can practice because otherwise the session will go by around 2 hours. मेरे ख्याल से भी हाँ yes. So we are going to solve 40 questions only, guys, in today's session. So these are the last 2 questions for the today's session, guys. The curve of unsteady state cooling or heating. Unsteady state cooling और heating का जो curve होता है वो कैसा होता है बच्चों? Unsteady state cooling or heating curve is what? Exponential curve. कैसा होता है? Exponential curve होता है. Asymptotic to time axis. ये जो curve होता है, this is asymptotic to time axis. So this is temperature. This curve is exponential asymptotic to time axis. So answer क्या हो जाएगा? Exponential curve asymptotic to only time axis, not temperature. Temperature के साथ asymptotic नहीं होता. This is asymptotic to only time axis. Question number 40. So there is a fluid flows over a flat plate. Dynamic viscosity this, specific heat this, thermal conductivity this. The hydrodynamic boundary layer is this. So hydrodynamic boundary layer is given to you 0.5. Is asking you the thickness of thermal boundary layer. You know, guys, we are having a relationship delta by delta thermal is equal to Prandtl की power 1 by 3. So if you know the Prandtl number, easily you can calculate this. If you know the Prandtl number, easily you can calculate delta thermal by equating this and this. So Prandtl number is what? Prandtl number is a ratio of the momentum diffusivity, means the kinematic viscosity, to the thermal diffusivity. Prandtl number is ratio of nu by alpha, momentum diffusivity to the thermal diffusivity, and it is nothing but mu Cp by K. So how much is mu? Mu is this 25 into 10 ki power minus 6. How much is Cp? Cp is this 2 kilojoules. So this is 2 into 10 ki power 3 SI unit. How much is conductivity? This is conductivity. You can write it as 50 into 10 ki power minus 3. So this is 0.005. Na? 0.005. I'm writing it as 50 into 10 ki power minus 3. Okay. Solving this will cancel out, and remaining 10 ki power 3 will be cancelled out from this. And this is 25 into 50. 50 by 50. You will have what? 1. So Prandtl number will come out 1. And if Prandtl number is 1, you know, Prandtl number is 1 means delta is equal to delta thermal. If Prandtl number is equal to 1, delta equal to delta thermal, it means if boundary layer, hydrodynamic boundary layer thickness is given to you 0.5, then thermal boundary layer thickness will also be 0.5. Option B क्या हो जाएगा बच्चों? Right answer हो जाएगा. Fine. Option B is the right answer. Guys, let me share here, show you the question so that you can take screenshot and you can try to answer in the comment box, comment section. Okay. इसको देखो, this is question number 14. I'm not giving you much time, guys. You need to try. Okay. You need to try, guys. There is some kind of time shortage is there today, so that's why I'm not completing all 50 questions. Sorry for that. You can try this question number 41, question number 42. Okay, please take some kind of screenshot and try to answer. Question number 43 and 44, these are also there in front of you. Question number 43. Okay, and this is question number 44. Please try. Okay, let me move to the remaining more questions. So this is question number 45. Question number 45. These are direct questions only, guys. These are not going to take much time. This is question number 46. 47. This is question number 47. This is question number 48. 48 is a good question. मैं इसको आपको एक बार समझा देता हूँ. 49. This is question number 49, guys. Okay. And this is the 50th question, guys. You need to try. देखो 50th क्वेश्चन तो बड़ा आसान है. क्रिटिकल रेडियस पूछ रहा है आपसे. डिटरमाइन द क्रिटिकल रेडियस, थिकनेस ऑफ इंसुलेशन. थिकनेस ऑफ इंसुलेशन पूछ रहा है आपसे. यू नो क्रिटिकल रेडियस क्या होता है? क्रिटिकल रेडियस इज k by h. तो k कितना है आपका? कंडक्टिविटी इज व्हाट? 0.1. h इज व्हाट? h कितना है आपका? 10. तो इसको सोल्व करोगे तो क्या आ जाएगा? इट विल बी 0.01 मीटर. या इसको मैं क्या लिख सकता हूं? इसको मैं क्या लिख सकता हूं? दिस आई कैन राइट इट एज 10 mm. ओके, सो क्रिटिकल रेडियस इज 10 mm. आपसे थिकनेस पूछ रहा है, कोल ऑफ डायमीटर 10 mm. ओके, आपसे क्या पूछ रहा है? कोल ऑफ डायमीटर 10 mm. तो इसका रेडियस कितना है बच्चों? हाउ मच इज रेडियस? रेडियस इज 5 mm. आउटर रेडियस इज व्हाट? 5 mm. क्रिटिकल रेडियस इज कमिंग आउट 10 mm. सो हाउ मच इज द थिकनेस? अब थिकनेस क्या हो जाएगा? द थिकनेस ऑफ इंसुलेशन, क्रिटिकल थिकनेस इज 5 mm, गाइस. Critical thickness, आपको only in this question you need to understand, he is not asking you critical radius, so don't answer 10. 10 आंसर करोगे तो गलत हो जाएगा. He is asking you the thickness of insulation. So the thickness of insulation, critical thickness of insulation is nothing but outer radius minus the critical radius. Okay, नहीं, critical radius minus outer radius. Okay, so this is the critical radius minus outer radius. So the critical radius is 10. We have calculated. The outer radius is 5 mm. So 10 minus 5, you will have this. चलिए इसको आप देखना, ये थोड़ा सा डायरेक्ट क्वेश्चन है. ओके, दिस इजीली यू विल बी एबल टू फाइंड आउट इफ यू विल इक्वेट. लेट मी रीड दिस क्वेश्चन फॉर यू. दिस इज a slightly different good question. Consider steady state 1D heat conduction between two parallel plates. तो ये दो parallel plates है बच्चों. These are the two parallel plates. And what he's saying, consider one dimensional heat conduction. इनके through one dimensional heat conduction you can consider. Okay. Now what is saying, guys? The heat transfer, here the one side the temperature is 300 Kelvin, here the temperature is 200 Kelvin. Okay, the thickness is also given, they are having this much distance and they are filled with air. दोनों के बीच में क्या है? Air. The air is filled between the two layers. Okay, the air is filled between the two layers. Now what is saying, the heat transfer is this 369 watts. If the temperature of air increases, अगर आप air का temperature बढ़ जाता है, so heat flow rate through the temperature, neglecting the convection and radiation effect. So heat transfer rate through the temperature of the plate T2. So T2 पे क्या effect आएगा? If the temperature of the air increases, then for same heat flow, what is asking you guys? The air temperature is increasing. Air का temperature क्या हो गया है? बढ़ गया है. Now for the same heat transfer, the T2 is going to what? Is going to remain same. T2 is going to decrease. T2 is going to increase. What do you will answer, guys? बहुत अच्छा क्वेश्चन है. What is asking you? These two plates are separated by air. So if temperature of the air is increasing, what is actually telling you indirectly is telling you the air conductivity is going to increase because air is a gas. Gases ka conductivity increases with the increase in temperature. So as the temperature is going to increase, its conductivity is also going to increase. So more is the conductivity, less will be the temperature gradient, means this T2 is going to increase. If the conductivity of air is going to increase, so Q is same. You know, Q is directly proportional to K. Okay, but actual में Q, for same Q, what is Q? Q equal to Ka minus Ka dt by dx. Okay, so if K is more is the conductivity, means temperature gradient will be less. For the same Q, guys, for the same Q, if conductivity is higher, the dt by dx will be lower. That's why this T2 is going to increase. Answer क्या हो जाएगा? B is the right answer. Okay, तो ये कुछ अच्छा क्वेश्चन था, that's why I discussed this also. This is very direct simple question. Radiation free convection में the Nusselt number is a function of the product of Grashof into Prandtl की power m, or this m equal to 1/4 for laminar, okay, and this m equal to 1/3 for turbulent. So this Grashof number is nothing but G beta delta T LQ by nu square. That's why you can answer here, sir, for the heat transfer rate free convection, the H is directly proportional to what? Delta T की power 0.33. Why? Because 1/3 you will have 0.33. Option C आंसर हो जाएगा. ये तो आप आंसर कर ही सकते हो. ओके, जब कंडक्टिविटी क्या होता है, इफेक्टिवनेस इज लेस देन 1, तो फिन कैसे काम करता है? फिन लाइक से इंसुलेटर. इफेक्टिवनेस लेस देन 1 मींस Q actual, Q with fin is less than Q without fin, means fins are working like a insulator. तो इसको आंसर कर लेना आप. चलिए, this 44 45, this is also direct question. बहुत ही direct question है बच्चों. Easily you will be able to answer, equating the using the Wenk's displacement law. Okay, and yes, this is also you will be able to answer. Mass transfer, ratio of convective heat transfer to the diffusive, that is known as what? इसको हम क्या बोलते हैं? This is known as convective mass transfer to the diffusive mass transfer, that is known as Sherwood number. This is just like Nusselt number only. Nusselt number is a ratio of Q convection to the Q conduction. Heat transfer by convection to the heat transfer by conduction. Diffusion is nothing but conduction. So Sherwood number is similar kind of Nusselt number, or it's a Nusselt number in mass transfer, because it is a ratio of convective mass transfer to the diffusive mass transfer. Scavenge number is, this is very much similar to Prandtl number. Prandtl number क्या होता है आपका? This is nu by alpha, okay, and this is what? This is nu by d, where nu is the momentum diffusivity and d is the mass diffusivity. So the ratio of the momentum diffusivity to the mass diffusivity is Scavenge number, okay, and the ratio of momentum diffusivity to the thermal diffusivity is your Prandtl number. Okay, so please solve these two questions. I hope these things are very much clear. So thanks for the today's session, guys. I'm going to end this session. So these are the 50 questions we have solved in today's session. Some questions I have not solved. I hope you can understand. Mostly that I cannot say at this particular moment when you can expect the exam, but I feel they're not going to conduct the exam before September. At the end of the September, I mentioned in the beginning also, September end पे in the beginning of October they can conduct the exam. There is no chance of conducting exam in this month August या next month के शुरू में. Okay, so I hope you are having 2 months minimum you are having. Okay, so they can conduct exam in the end of September or the start of October, because based on the last year scenario, because last year also they have given 3 months. Okay, last year उन्होंने 3 महीने दिया था. That these are just kind of prediction. Okay, actually में the things are much uncertain, but yes, I think you can go with that. Minimum 2 months they are going to give you. Chale guys, thank you very much. Keep preparing. Again we will meet and we will solve some more question. Thank you. Good luck.